So we covered everything that was new in the first video of this, and so this is just kind of applications. If you got those formulas memorized, then really that was all the point of the first video. I'm going to do a couple problems out of this section, and that will be the same type of problems out of section 39 to 44. And then I'm going to do a couple of the verify the identities, and then really after that you're just playing around with different things. I wanted to do these couple problems from here just because of the difference of what's going on. We're going to have to use a lot of our previous knowledge to understand this, and you got to just start with what we're given, and so that we have these two angles, and they're telling us that they're both in quadrant 2. That's going to be important because of our negative and positive signs. So I'm just going to sketch what those look like and to see what we can come up with. So this can be, we'll call this U. And sine, right, SOHCAHTOA, sine is opposite over hypotenuse, and so that's going to be a 5 and a 13. And then we're going to finish off this right triangle by doing quadratic formula. Pythagorean's theorem, and I'll save you the work on that. But then when you do that, you find that the other side is 12. And since we're in the second quadrant, that means our x value has to be negative, and so that's going to be negative 12 there. And we'll do the other one as v. And they say that it's negative 3 over 5, and SOHCAHTOA again, adjacent, so negative 3 over hypotenuse. And this would be a 3, 4, 5 triangle, but of course you can find the missing side on that one the same way by using the Pythagorean theorem. So now we have a bunch of information, and we do see that we're going to have to apply the difference cosine formula here. So I'm going to write that out so we can see it, and I'll have to move back and forth so we can see everything here. And of course they wrote it a little bit differently. They switched their U's and V's on us, so that's kind of obnoxious. But we're going to find the cosine of V times the cosine of U plus the sine of U. Oh, I'm sorry, I guess the sine of V, if you're sticking with the formula, times the sine of U. It doesn't really matter the order on this one. But that would be using the formula. Now, what are all these things is what the real question is. And the key thing to understand here is that, this formula is for angle measurements. But we weren't given any angle measurements. We were just given the ratios of the sides. So we're going to have to use our inverse trig functions to find the actual angle, because this formula only works with angles, and again, we don't have those yet. So I'm going to use arcsine as the inverse function, and I'm going to fill in that. So I kind of don't have enough room to show everything at once, but what we have here is V, the cosine of V, being negative 3 over 5. So then really what we're doing is doing cosine of V is negative 3 over 5. And then we have this cosine of U, but we don't really know what the cosine of U is right off the bat, and maybe you can see it already. But the proper step would be to write it as cosine of arc sine, because that was the information we had, of 5 over 13. Okay, this I guess is maybe a little obnoxious, but what I did was, right, we really only knew this information here about the U, the angle U, and so I'm using what we've been given. And there's a shortcut involved that you will be able to see. I'm going to kind of go through it the way I feel it's kind of proper. Okay, so that's this first part here. Cosine of v was negative 3 over 5. Cosine of u is a cosine. Well, this is how we're going to find our value u, arc sine of 5 over 13. So I'll show you that here in a second. And then we have the sine of v. And again, we weren't given the sine of v. So I'm going to write it as plus the sine of arc cosine. And remember, arc is the same as inverse of negative 3/5. I'm going to run out of room here, but times the sine of u. Right, the sine of u there is 5 over 13. I can fit it in here. Okay, so how, we did this a while ago, but the way the cosine of arc sine works and the sine of arc cosine works is we're basically just going to the proper triangle and finding the cosine ratio. So I'm going to leave negative 3/5 here. We're going to go up to our first triangle here. There we go. And right, we're basically just finding the cosine here of u now. So then that's going to become adjacent over hypotenuse, so negative 12 over 13. Plus, we're going to find the sine of this one, so 4 over 5, times 5 over 13. And then we're just simplifying this expression. And we would get 56 over 65. Okay, so I'm going to run through another problem of those just so you can see it. I'll go a little bit quicker. Okay, so I thought I'd do one of the ones that is not the normal 3, so this is just going to be cosecant. I already drew the triangles back up there. Again, I just want to reiterate that the quadrant 2 was important for us to get our signs in the correct positive and negative signs. In the next section they talk about being in quadrant 3, so just be careful of your signs when you're setting those up. What I'm going to do here with cosecant is remember that it is 1 over sine. So all I'm going to do is actually find, this is like kind of like really what I'm going to do is just do sine of u minus v the same way, and then I'm going to take the reciprocal of that answer, and that will be the answer to cosecant of that. There are formulas that you can find that are obnoxious. This works just as good, so keep in mind that really what we're finding is this. So, right, this is going to be the same as, so right, this is sine of u, cosine of v, minus cosine of u, sine of v. Okay, and this one's kind of, I don't know if it's easier, but, right, we already know the sine of u and the cosine of v, right, from the directions. So the sine of u is 5 over 13. And the cosine of v is negative 3 over 5. Now we're going to use the arc sine notation, and really all that's doing is telling us which triangle we should be looking at. And so then it's the cosine of u, but I'm going to write it as cosine of arc sine of 5 over 13 times sine of v, but I'm going to write it as arc cosine of negative 3/5. Again, that's all just telling you which triangle you need to be looking at. So, if I can get it in here. So, the arc sine of 5 over 13, the cosine of that statement, just means that we're using this triangle, and we're going to find the cosine of that. So that would be negative 12 over 13. And then we're going to be using, for this statement, we're using this triangle. And so we're really finding the sine of v. And so that's going to be 4 over 5. And then if we multiply these two in the first term here, we get negative 3 over 13. And then we're just simplifying. And so that gets us down, when we combine all those, that gets us down to 33 over 65. But of course that was sine, and we were really finding cosecant. So then we take the reciprocal of that, and we get 65 over 33. Okay, so I'm going to just do two problems from this verifying the identity. And it's just like doing it from that other section. You want to start on the more difficult side and try to make it look like the easier side. And the only difference, we're still using all the identities from before. The only difference is we just introduced 4 new statements. Those the sum and difference formulas there. So I'm going to start here on the left-hand side, and I'm going to just apply the sum formula for sine. And so that would mean that it is sine of pi over 2 times cosine of x. And then that's going to be plus sine of x times cosine of pi over 2. All right, now we're just evaluating, thinking of the unit circle. Remember, your sines are your y's and your cosines are your x's. So that means sine of pi over 2 is 1 times cosine of x. And then sine of x. And then the cosine of pi over 2 is 0. And so then we get down to cosine of x. All right, so I just randomly picked number 52 because it looked, somewhat difficult. We're in the sum and difference formulas, so I am going to mess with the left-hand side first, and I'm just going to apply those formulas over there. I'm not going to keep rewriting the right-hand side of this because I won't have enough room. But sine of x plus y is the same as sine of x times cosine of y plus sine of y times cosine of x. And then the sine of x minus y is sine of x cosine of y minus sine of y cosine of x. All right, and the only thing it looks like that we can really try out is to FOIL all this. And so then what we would get is sine squared x cosine squared y minus sine of x sine of y cosine of x cosine of y. And then what I'm going to do here is write this next one underneath that one. So right, I just distributed this to there and then this to there. Now I'm going to go here, I'm going to write it underneath so that I can save a little room so you can see all this. So then it would be plus sine of x sine of y cosine of x cosine of y. And those are going to end up canceling. Then it's going to be minus sine squared y cosine squared x. Alright, so then after these two middle ones cancel each other out, we have sine squared of x cosine squared y minus sine squared y cosine squared x. Okay, now this is a good time to take a look at what we have over here. And we have everything in terms of sine. We have these cosines sitting there that we're going to have to deal with. And so, you know, I told you once before, anytime you see squares, you should be thinking of the Pythagorean identities. And I'm going to substitute in using the Pythagorean identities, and so that I can get rid of these cosines and write them in terms of sine. So then, so cosine squared y is really 1 minus sine squared y. And again, the reason I'm doing it this way is because I know that the answer I'm looking for is in terms of sine. Now that I have everything in terms of sine, I'm going to distribute the sine squareds that are out in front. So then I'm going to have sine squared x minus sine squared x sine squared y minus sine squared y plus sine squared x sine squared y. These add up to be 0, which is nice because now we have what we were looking for. Now I didn't get this one right off the bat. You know, it took me a second to think through it. I started factoring and all kinds of stuff. But like I said, when you're doing these verify identities, you just got to start somewhere and see where it leads you, realizing that you may not get it all the way on the first try. So please ask, let me know what I can do.